Okay, so this is the 2011 B test here. And let's do A. This is the probability that X will happen greater than or equal to 4. Okay, this is a geometric probability. So it'd probably be easier to say 1 minus the probability that X is less than or equal to 3. Okay, so let's do this math. So this is going to be 1 minus the probability that X is equal to 1 plus the probability that X is equal to 2 plus the probability that X is equal to 3. Okay, so it's going to be 1 minus the probability that X is equal to 1. So that means it's going to have one success, no failures, plus the probability of X is equal to 2, 1 success, 1 failure. The probability of X is equal to 2 is 1 success, 2 failures. Okay? So what I'm going to do here is I'm going to go onto my calculator and I'm going to go to 1 minus GOMCDF, because remember there's more than 1 here. 1 minus, and you go to distributions. Remember, it's been a long time. And I'm going to go to CDF. My probability of this X is 0.1, is going to be 3. Okay, so my answer is going to be 0.729. Okay? Okay, let's go to B. What's the probability that Sam will upgrade exactly 2 times in his next 20 flights? So I'm going to go to the next page. So this is the probability that X is equal to 2. This is a, go away, binomial. So this is 20 choose. There's no bar there, silly Schwartz. 20 choose 2 of 0.1 squared of 0.918, because 18 plus 2 is equal to 20. So I am going to go to distributions and I'm going to go to binomial. And then now this is a PDF because there's just one. So it's 20 trials 0.1 and 2. And I get 0.2852 because I get 179. Okay. Now I have to go see, what does the third one say? Okay, so Sam will take 100 flights next year. Would he be surprised if Sam receives more than 20 upgrades to his first class? Justify your answer. So you know, this is going to be standard deviation, okay? Okay, and so we have 100 flights. So my mean is equal to n times p, which is 104 times 0.1. What is that, 10.4? I should know this. I'm tired too. Which is 10.4. And I'm going to find my standard deviation, which is n times p times q, which is 104 times 0.1 times 0.9 times 0.9, and then I take the square root of my answer, and I get 3.06. Okay, and I want to know if I'm surprised. So if I'm more than 2 standard deviations from the mean, so the probability that X is more than 20 is equal to, let me go to the next page. The probability that X is more than 20, so So my mean is equal to 10.4 with a standard deviation of 3.06. Here is 20. Okay? So remember the math is going to be 20 minus 10.42 divided by 3.06. So 20 minus 10 point, just 10.4 Schwartz. Where did I get this 2 from? I guess I'm tired. Divided by 3.06. And I get 3.13. And I would say yes, since 20 is more than 3 standard deviations away from the mean. You remember this stuff? Okay, so I chose to do number 4, also in 11b, and this is a chi-squared. And look at what it says here. Determine whether there's an association between the effect of part-time work on academic achievement. Did you hear that belch? I'm sorry. And the average number of hours worked. Okay, now I can't show everything here, so I'm going to go to the next page. And here's all the expected values. Okay, now look what A says. State the null and alternate. Okay, so let me do A up here, and I'm going to have to erase it. So HO. Now I'm going to use that wording that they use, and I'll say the effect of part-time work, the effect of part-time work on academic achievement and the average number of hours worked is independent of the average number of hours worked. Okay, now you can't do this, but then HA would be the same thing, but they would change independent to dependent. Okay, don't do that. You have to write it all out. All right? Okay, so discuss whether the conditions for a chi-squared inference are met for this data. So do they talk about how they were chosen randomly? So can the conditions for B, random is stated. Each person's effect. What is this? The person, the number of hours a person worked and its effect and their effect has been recorded. The number of hours each person worked and their effect has been recorded. We have to prove that it's categorical data. And then the last one is expected value, and that's why they gave you this table here. And so what do we know? That all expected values are greater than 5. So then I would say all expected values are greater than or equal to 5. Okay, so let's go to C. And they give me my p-value, and so I'm going to say we will, sorry, this thing drives me crazy, reject HO since my p-value of 0.007 is small. Okay, there is evidence to suggest that the number of hours of part-time work, then the average, the effect of part-time work on academic, the effect of work, of part-time work, I'm just kind of rewriting that statement, on academic achievement is dependent on number of hours worked. All right, so let's go to D. Okay, based on your conclusion, which type of error, type 1 or type 2, might the advisory have made? Describe the error in the context of your question. All right, so I don't really have stuff to write here. So because we rejected the HO, type 1 error might be made, and so describe the error in the context of this. So the error would be is that they decided that there is an effect on the number of their opinion on their academic achievement and the number of hours that they worked, when in fact there isn't any effect on it. All right.